to a slightly more complex scenario. Let's take the meter stick and move it. Well, first off, let's establish that the center of mass of the meter stick doesn't move, nor does its force, 1.4 newtons. When I say force, I mean force due to gravity, and by force due to gravity, of course, I mean weight. Now, let's go ahead and cut one of these strings again. This is kind of an arbitrary deal. And let's go ahead and black out these forces, so we don't know what we're dealing with, okay? And let's demonstrate that we can discover the actual force that these two things read by using rotational statics and translational statics. So let's say we cut this string this time. Alright, now that means that over here this will be a point of rotation. And now the weight of the stick will cause a counterclockwise torque. Since we know the torques in the counterclockwise direction have to be equal to torques in the clockwise direction, we can set up, we'll just say that it's at static equilibrium, counterclockwise torques must be equal to clockwise torques. Kind of make my T funky, otherwise you'll get it confused with an actual T. So, torque being, of course, force perpendicular times radius. Alright, well, let's go ahead and get some information. We know the force that's causing the torque in the counterclockwise is 1.4 newtons. All we have to do is take that times the radius. Now if we come over here, although it's difficult to see, it turns out that this is at a position of 0.75 meters, or 75 centimeters, and we have 50 over here. So the difference between 50 and 75 is, that puts this at a radius of 0.25 meters. So I take it times 0.25 meters. Now when I set them equal, what I'm really looking for is the force. We're going to call this FT1. This one's FT2. I want to know what FT1 is. What's that thing going to read? Well, we can say, okay, we know this radius, if we measure all the way out to here, that was 75, and this is 5, so a total of, for a total radius of 0.75 meters. So what we can do is we can figure out the force of tension that's reading on that particular scale by taking and dividing through by the 0.75 meters. Cancels out on this side, and we'll be left with FT1. So, what is 1.4 times 0.25 divided by 0.75 anyway? Well, if I get out my handy-dandy calculator, it tells me that FT1 should read 0.47 newtons. So let's go ahead and clear this off and see what it says. Well, it looks like it's dang near 0.5. 0.47. Seems good to me. So now, wait a second. How do I figure this one out? Well, I could go through and do it the hard way, where I imagine I cut the other one and do the rotational statics. However, I know that the sum, I know that the sum of FT1 and FT2 in the up direction have to fully cancel out the weight of the stick. And since I actually know FT1 is 0.47 newtons, I just have to subtract that from the 1.4. So I take 1.4 minus 0.47, and I get a value which is equal to FT2. And I get 0.93 newtons. So I can erase this, and I'll be danged if it's not almost 1, slightly under 1.